Welcome to everyone. Today class I will discuss about the expansion in liquids and gases. When heated, the atoms in a liquid or gas gain energy and are forced further apart. The extent of expansion varies from the substance to substance. Already we know this. We have studied this one in previous session itself. The extent of expansion varies from the substance to substance. Why? Because the expansion of the substances depends on the nature of the substance and the mass of the substance. Underline these two terms. The extent of expansion varies from the substance to substance because the expansion of the substances depends on the nature of the substance and the mass of the substance. For a given rise in temperature, a liquid will have more expansion than a solid. Listen please. In this earth crust, there are two states of substances. One is solid state and second one liquid state, then finally gaseous state. Now the range of expansion of the substance from these three states when it is heated means a liquid will have more expansion than solids. Why? That is very simple, because the interatomic distance between the atoms in that substance is higher. For a given rise in temperature, a gaseous substance has the highest expansion when compared to solid and the liquid. For this also only the main reason, the interatomic distance between the atoms in that substance is higher for gas, somewhat lower for liquids and large lower for solids. I have written like this: the expansion range of three states of substances, that is gas greater than liquids greater than solids. The main reason is the interatomic distance between the atoms in that substances. Gas is greater than liquids is greater than solids. About the interatomic distance and intermolecular distance we will read very deeply in our higher classes. The coefficient of cubical expansion of liquid is independent of the temperature. Underline, this is very important point. The coefficient of cubical expansion of liquids is independent of the temperature. But one more thing we want to listen, the coefficient of cubical expansion of gases depends on the temperature of the gases. Heating a liquid without using a container is not possible. One time I will repeat this. We want to heat a liquid without container is impossible. For example, we will take a iron rod, then applying heat of one end of this iron rod means that heat transfer throughout the iron rods. But we want to raise the temperature or heat the liquid means definitely we need a container to pour that liquids. Otherwise we can't able to heat the liquids with our knowledge. Thus in practice we need to heat any liquid by pouring it in a container and supplying heat energy to the liquid through the container. A part of thermal energy is used in expanding the container and the remaining part of the energy is used to expanding the liquids. What is meant by that? We will take a solid material or medium means applying heat fully used for heating that solid substance, but in the case of liquids without container we can't able to heat any liquids or raise the temperature of any liquids. For that additionally we need one more medium, that is container. Now we will apply heat energy. I have filled this some liquid in this container, then supplying heat energy to this liquid system for raising the temperature of this liquid means from this applied heat energy one part of energy is used to heating this container and another part of energy only used to increase the temperature of this liquid. In this case there are two mediums presenting, initial medium container, then secondary medium only liquid, because of the liquid will be inside of the container. Our supplied heat initially transferred to the container, after heating or reaching some quantity of temperature of that container only the liquids will get heating. That only we can say a part of thermal energy is used in expanding the container and the remaining part of the energy is used to expanding the liquids. Thus what we observe? From this we will observe there is no possibility to observe only the actual or real expansion of the liquids. In our case only the liquids will be present means we will observe that real expansion only, but in our case there are two mediums are presenting, one is liquid and another one is container. That is what we can't able to observe only the real expansion. Then additionally possible to there is a possibility to observe two types of expansion as follows, that is real expansion and a apparent expansion. First we will study about the real expansion of the liquids. If a liquid is heated directly without using any container, then the expansion that you observe is termed as the real expansion of the liquid. It is possible? No. Our answer is no. Already we know that practically it is impossible. Then definition of coefficient of real expansion. Already you got clear idea about the coefficients of types of expansion in solids. According to that expansion only we will derive the coefficient of real expansion. The coefficient of real expansion is defined as the ratio of the true rise in the volume of the liquid per degree rise in temperature to its unit volume. That is expressed like this. That means the ratio of the change in volume with respect to original volume due to the change in temperature. That means the change in volume is directly proportional to change in temperature with respect to its original volume. That only I have written here. See here. Change in volume of the liquid with respect to original volume is directly proportional to change in temperature. From this what we can understand? The temperature of the liquid changed means the volume of the liquid also changing, because of the liquid will get expanding. In other words, we can say the rise in temperature is in proportion to the amount of heat energy supplied. The amount of heat energy supplied is directly proportional to the change in volume of the liquid with respect to original volume. Here I will introduce a relevant constant, that is alpha R, that only coefficient of real expansion. That means del V divided by V naught is equal to alpha R into del T. From this I am going to derive the expression for alpha R, that is equal to this del T comes to left means goes to denominator, then alpha R is equal to del V divided by V naught into del T. I will determine the unit of coefficient of real expansion. Change in volume means the unit will be meter cube, and the initial volume also meter cube. Then for temperature Kelvin. Meter cube balanced, then remaining 1 divided by K, that is nothing but K inverse. From this we can conclude the SI unit of coefficient of real expansion is K inverse, that means Kelvin inverse. The fundamental unit of temperature is Kelvin. Once again we will recall the physical quantities which is present in this case. Alpha R means coefficient of real expansion, del V means change in volume, that is represented by the difference between final volume and initial volume. V naught is initial or original volume of a liquid, then del T change in the temperature, that is denoted as the difference of the final temperature to initial temperature. Next we will see about that operant expansion. The expansion of a liquid apparently observed without considering the expansion of the container is called the apparent expansion of the liquid. Once again we will increase the temperature of the solid medium means we are applying external heat energy. The total heat energy used to increase the temperature of the solids, then that solid medium will get expansion. There are three types of expansion in solid medium occurs. Already we have studied well, but in the case of liquids there are two mediums present when we want to heat the liquid. One is container and another one is our liquid. Then we are applying external heat energy to that whole system means initially the container want to be heat, then only afterwards only the liquids will get heating. From this we can understand the one part of energy from the applied thermal energy is used into heating the container, and the another part of energy is used to heating the liquids. so that there are two types of expansion in liquids will be appeared. One is real expansion, that is already we have studied. Then second case will be apparent expansion. Apparent expansion means the expansion of the liquid observed without considering the expansion of the container. Then coefficient of apparent expansion, these are same things for all the coefficients of expansions. That is, coefficient of apparent expansion is defined as the ratio of the apparent rise in the volume of the liquid per degree rise in temperature to its unit volume. Real and apparent expansions like volumetric or cubical expansions. That means the change in volume is directly proportional to change in temperature with respect to its original volume. In other words, we can say the rise in temperature is in proportion to the amount of heat energy is supplied. That is written in the form of expression del V divided by V naught is directly proportional to del T. Here I want to apply some relevant constant, that is alpha AP. This is representing the coefficient of apparent expansion. Then the above expression is rewritten as del V divided by V naught is equal to alpha AP into del T. From this we want to derive the expression for alpha AP, that is equal to del V divided by V naught into del T. Then finding the units means for change in volume meter cube and also original volume meter cube, then change in temperature Kelvin. Meter cube cancel, then remaining 1 divided by K, that is nothing but K inverse. The SI unit of coefficient of apparent expansion is K inverse, that is other words Kelvin inverse. Once again we will recall the physical quantities which are present in this apparent expansion. That is, alpha AR is coefficient of apparent expansion. Del V change in volume, that is denoted as the difference between the final volume and initial volume of the liquid, and V naught is the initial or original volume of the liquid, and also del T is change in the temperature, that is represented like the difference between final temperature and the difference between the final temperature and initial temperature of the liquids. Thank you for listening.